Hi, welcome to ElimuHub. In this tutorial, I'm going to solve a conditional probability question involving algebra. A bag contains counters that are either green or blue. There are n green counters. The number of blue counters is one more than the number of green counters. Two counters are taken out of the bag at random without replacement. Show that the probability that both counters are the same color is this one. So this is what we need to show. So let's just start by putting together what we have got. So let's have a look at green. What's the number of counters? It's n. And blue is going to be one more. So it's n plus 1. So the total number of counters then is adding these two. So that's n plus n is 2n plus 1. So the total number is 2n plus 1. Now let's just calculate the probabilities of each color. So probability of getting a green counter is going to be n over 2n plus 1. And probability of getting a blue counter is going to be n plus 1 over 2n plus 1. But we want to have two counters, so we have to show all the possible outcomes. Well, we can use a tree diagram to do that, or you can simply say, well, actually, I'll do tree diagram. So if we have the first event, I could get a green or blue. And when I select my counter the second time, I could get a green or blue. Similarly, if I had a blue, the next time I take a counter, I could get a green or blue. Now the root that you are interested in is green and green, blue and blue. So we don't need to fill in everything, but it's a good exercise if you want to. Right, so the first time a chance of getting a green counter then is this one, is n over 2n plus 1. And my chance of getting a blue counter the first time is n plus 1 over 2n plus 1. Now I've taken one counter out, which means now I have one less counter altogether. So my number of counters are now going to be 2n plus 1 take away 1, which is now 2n. And if I did take a green out, then I have one less green, which means now my green is going to be n minus 1, and my total number of counters is now less 1, so it's going to be 2n. So that's green, green. And now if I go this way, if I had a blue first, then I have one less blue, so n plus 1 take away 1, which is going to be n. Also, my total number of counters now is 2n. So what we want is this root here and this root here. Okay, and then add them up. So we multiply across, if you remember your probability trees, and then we add as we go down. So let's just do probability of getting green and green. Okay, because it is algebra, we just do one at a time. So n over 2n plus 1, and then this multiply by the second branch, which is n minus 1 over 2n. It's better if you can cancel out anything that you can here. So I can see there's one n there and there's another n here. I can cancel because I'm multiplying, and now this can simplify to n minus 1, and down here is going to be 2n times 2, which is 4n. 1 times 2, and it's plus, so it's plus 2. So this is probability of getting green and green counter. Now let's do probability of getting a blue and blue counter. So I'm taking now this root. Okay, so the first time I have n plus 1 over 2n plus 1. Then I multiply. The second time I have n over 2n. Okay, again I can simplify this and that, and now we just give me half there. And then I just multiply, so I get n plus 1 over 2n times 2, so that's 4n plus 2 down here. So that's my probability of getting blue and blue. So probability of getting the same color then is now is the addition of the two. So it is going to be this one here, so n minus 1 over 4n plus 2, add this one here of getting blue, which is n plus 1 over 4n plus 2. Now they have the same denominator, so all I have to do is just add the top. So n plus n is going to be 2n minus 1 plus 1 is 0. So now I'm just left with the denominator, which is this. I can cancel out by dividing by 2 throughout. Okay, so I'll be now left with n over 2n plus 1. So my probability of getting the same color is going to be n over 2n plus 1, which is what we are asked to show. That's it. I hope you have enjoyed the session. Thank you for watching.